Rust is one of those rare languages that makes documentation and testing not only easy, but actually enjoyable. And I'm going to show you exactly why that's the case. We'll walk through writing good docs, embedding examples that automatically test themselves, creating unit tests right inside your modules, and building full integration test suites. Let's start with documentation, because good docs are part of what makes Rust so loved by developers. Rust uses a markdown-based documentation style called doc comments, which are written using triple slashes like this. Now let's break this down. Those triple slash comments sit right above the function they document. When we run cargo doc, open, Rust will automatically generate beautiful documentation pages with clickable modules, syntax-highlighted examples, and links. The examples section appears as a special header, and the little code block inside the triple backticks? That's not just for show, it's actually a test. These are called doc tests, and they run every time you run cargo test. So if your documentation example ever stops working, your tests will fail and warn you. This is a killer feature because your docs and code never drift out of sync. Let's write our own crate to see this better. Let's create a small library, math tools. Inside librs, write a simple function to multiply two integers. Notice how natural this feels. And if we now run cargo test, any example you've included in your docs gets executed. This is future-proof documentation. Now let's move on to unit testing. Unit tests in Rust live in the same file as your code, usually inside a special tests module marked with conditional compilation attribute. CFG is short for configure or configuration. Let's expand our math tools crate by adding a couple unit tests. Let me walk you through it. This attribute tells Rust to only compile that module when we run cargo test. Mod tests is just a normal module, but it's private. Inside it, we bring everything from the parent module into scope using a glob import. Use super. Then each test function gets the test attribute. If we run cargo test, Rust finds all of these test functions automatically and executes them in parallel. The output will look something like this, running two tests, test multiply positive numbers and test multiply negative. Unit tests are meant to test small, isolated pieces of functionality, perfect for pure functions or internal logic. Rust even lets us test functions that are supposed to panic. Let's say we write a divide function with division by 0 check. If the divisor is 0, the function calls panic, division by 0. Now let's test that panic. The should panic attribute is the core of the test's logic. Instead of checking for a successful result, this attribute tells the test harness that the code is expected to panic, crash gracefully, when executed. Expected equals division by 0. It doesn't just check if a panic occurs. It checks if the panic's error message contains the string division by 0. The test passes only if both of these conditions are met. The call to divide function panics, and the panic message contains the text division by 0. If the divide function call panics, but the messages say, oops, something went wrong, the test will fail because the message didn't match the expected string. The test will also fail if the code executes successfully without panicking. This is extremely helpful when you need to enforce invariance or guard against invalid input. Unit tests are great for testing isolated functionality, but sometimes you want to test the public API of your entire crate. For that, Rust gives us integration tests. These live in a separate directory, tests. Let's create one. Create a new folder, tests. Inside this folder, create a new file, integration test.rs. Inside integration test.rs, write this test function. Notice something different. We didn't import items using super anymore. Integration tests treat your crate as its own external consumer, just like another developer would. This ensures your public API works the same way you expect downstream users to experience it. If we run cargo test, Rust will run unit tests first, and then integration tests. You'll see output like this, running one test, test multiply integration. This separation between unit tests and integration tests keeps your project clean and makes sure you're testing both the internals and the public-facing behavior. Sometimes you need setup code, like reading a config file, creating temporary directories, or initializing a logger, and Rust makes that possible using plain Rust. Let's create a simple example. Suppose we create temporary files for testing. This unit test verifies that a file can be successfully written and read within a temporary directory that is automatically cleaned up when the test finishes. The temp file crate automatically deletes the directory when the variable goes out of scope. Rust's ownership model makes cleanup natural and predictable. No need for teardown or after hooks. Rust's documentation system doesn't stop with functions. You can document modules, structs, enums, traits, methods, entire crates. For example, look at this documentation. The /! Comments document the entire crate or module. The / comments document the item immediately following them. With cargo doc, open, all of this becomes a beautiful rendered website documenting your whole project. And there you go, documentation, doc tests, unit tests, integration tests, panic tests, and module-level documentation, all in one cohesive system. One of the coolest things about Rust is that your docs and tests are first-class citizens. Writing great documentation encourages you to write great examples, and writing those examples automatically gives you real tests. The ecosystem pushes you toward readable, reliable, maintainable code.